Okay, I have a couple additional examples I want to show you that will help you with the special cases you'll come up with or against in circuits 2 and 3. So they're going to ask you about solving these trinomials mostly. And so just a reminder that if we are asked to solve something, we will set it equal to 0, we will factor it, and then we'll set each individual piece equal to 0, and that gives you your solutions, zeros, however they word it. Okay, so if we have to factor x squared minus 6x minus 40, we need something to add to negative 6 and multiply to negative 40. So we make our little table here. 40 is made up with factors, so we need one negative and one positive factor to multiply to get 40 and to add to give us a negative number. So we could have negative 1 and 40, negative 2 and 20, 3 doesn't work, negative 4 and 10, negative 5 and 8, 6 doesn't work, 7 doesn't work, negative 8 and 5. Let's just check and see if we have our answer. So we have 39, 20 minus 2 is 18, 10 minus 4 is 6, 8 minus 5 is 3, 5 minus 8 is negative 3, and we've got to go one more, negative 10 and 4, negative 10 plus 4 is negative 6. So that is my pair that I need. So I need x minus 10 and x plus 4. Then you have to set each of these equal to 0. So x minus 10 equals 0, x plus 4 equals 0. How do I solve for my variable? I always do the opposite. So subtracting 10, I need to add 10 to both sides and get that x equals 10. Or this is adding 4, so we'll subtract 4 and get that x equals negative 4. Okay, those are your possible answers. So if it asks you to solve and find a solution, don't forget, factor, set it equal to 0, and find those answers. All right, also they're going to ask you to simplify a rational expression by factoring. We did this year already. So just remember, do whatever factoring you can, and then see what can cancel. So you have to see, can you factor this polynomial? Can you factor this polynomial? X minus 5 is already down to a binomial, so we can't do anything there. Let's try to factor x squared plus 2x minus 3. The only factors of 3 are 1 and 3, so that should make it easy. And which one needs to be positive and which one needs to be negative to get our negative 3 here? Well, we have a positive 2, so we need positive 3 minus 1. Negative 1 times 3 is negative 3. Negative 1 plus 3 is 2. Okay, so that's factored. Then try and factor the bottom. X squared plus 8x plus 15. So 15 is either 1 and 15 or 3 and 5. Okay, so we have to add to get 8. Multiply to get positive 15. So we need all positives. We have to use 3 and 5. Plus 3 plus 5. Then we cancel things that are identical. These are polynomials divided by polynomials. So if they're identical, we can cancel. So x minus 5 cancels with x minus 5. X plus 3 cancels with x plus 3. We are left with x minus 1 over 1, or just x minus 1. So that's your answer. I was going to give a reminder there, but I don't remember what it was. Oh, yes. If you can't factor it, can't find the numbers. Reminder, what do? Trouble factoring, you're stuck for an hour on a problem. That would be horrible. Use the quadratic formula. If you use it, use that as your work on your paper so I can see that that's what you used. But if you need it, it is negative b plus or minus b squared minus 4ac all under the square root bar over 2a. Okay, if you really just can't figure it out, use this. If you end up with a negative number under this bar, that it's not a factorable thing. Okay, so that's how you can check for your primes. You can check for problems where you just cannot figure out the answers. Use the quadratic to see if you're just spinning your wheels on something that's already prime. Okay, then we have something needs factored. It's a little more complex. We have a trinomial. So our table from yesterday, remember, always try taking out a GCF first. 3, we have a general trinomial, possibly perfect square. Look for that GCF. Okay, so what do these terms have in common? 3xy squared, okay, 21xy and negative 132x. If you're not sure that you're going to catch everything on your own, do what we've done before. Prime factor. 3xy, 21, oh wait, y squared, 21xy, negative 132x. Alright, so 3xy squared is 3 times x times y times y. 21 is 3 times 7, so 3 times 7 times x times y. 132, that's a little more complex. Let's go ahead and tree that. 2 would be definitely divisible by 2 because it ends in 2. 2 goes into 13 6 times, that's 12. It leaves 12. Alright, so that's 61. What am I doing wrong there? Hang on. Just gonna check my math. 132 divided by 2. Ah. Duh. 66. 2 goes into 13 6 times, leaves a 12. 2 into 12 is a 6. Okay. Too much mental math in my head. Alright, so factor again. 66 is divisible by 2 as well. So 2 times 2 and 33. 33 is 3 times 11. 3 and 11, and it has an x. So we need to identify what do these have in common. They have a 3, so we're going to circle the 3 in all 3 terms. Not just 2 of them, all 3. What else do they have? They also have an x. No other numbers in common. This one doesn't have a y. So your GCF that goes out front will be 3x, and then we'll write the remaining pieces as our polynomial. So 3x, that leaves 2 y's, so y squared. 3 times 7 plus 7 times y. Oops, I forgot to write my negative 1 times. So negative 1 times 2 times 2. So negative 4 times 11 minus 44. And there are no variables left. Now we have to see, can we go any further? 3x is done. I can't go anywhere else with that. Can I find factors of 44 that give me 7? It's negative 44, so I know I need a negative and a positive. 44 is 1 and 44. 2 and 22. 3 doesn't work. 4 and 11. 5, 6, 7, 8, 9, 10, 11, and 4. And then 22, 2, 44, and 1. And remember I said this is negative. Excuse me, the 44 is negative, so it must have 1 negative and 1 positive column. We need to find the pairing here that gives us 7, adds to be 7. So that will be negative 4 plus 11 is positive 7. So we'll choose that. we will write our factors. So this is y, make sure you use the right letter, y minus 4 and y plus 11. So you would be looking on your circuit for either 3x, y minus 4, or y plus 11. Okay. Okay, the next one I want to do is a polynomial that is not just a regular x squared and x, so it has a higher power. And these are really simple. You just have to take them one step at a time. So what do we notice about this? What do we notice about this problem? What does it have in common? Check for your DCFs first. 8x to the fourth, 18x squared, and 4 all have factors of 2. So let's start by taking out that factor of 2. So 2 times 4x to the fourth minus 9x squared plus 2. Okay, because we're set equal to 0, we can also divide by 2 and just make that go away. Okay, now we're just factoring 4x to the fourth. Wait a minute. Yeah, 4x to the fourth minus 9x squared plus 2. Okay. This is basically two things. This is bottoms up. And this is x to the fourth and x squared are both squares of what we're used to, right? This y squared and y. So we're going to say that x to the fourth is just the same as, goodness. This is the same as x squared squared. Okay, and x squared is just x squared. So instead of using what we normally do, we take an x squared and we make it an x. We take an x squared, we make it an x. We are going to double that. Okay, so instead, we're going to start with a square here. And it will help us get what we need. Okay, so the leading term is what you look at. This, as long as they're the same, will help you get where you want to be. All right, then we have to talk about these parts. So we take a times c, or let's see, we're going to add to -9. That part doesn't change. We're going to multiply for bottoms up to a times c, or 8. What factors of 8 add to -9? So if it's negative here, this needs to be a negative and a negative. All right, so 1 and 8, 2 and 4, those are your only factors of 8. So which ones add to give you -9? -1 and -8. So we're going to have -1, -8, and we have to bottoms up what was, oh shoot, sorry guys. So they add to -9, we multiply to a times c, which is 8. I wrote my factors of 8, -1, -8, -2, -4. We have to remember to bottoms up with a, which was, in our polynomial, it was 4. We divided everything by 2, so we continue with this 4. We're going to divide everything by 4, so this will be x squared minus 1/4 times x squared minus 2. This one we don't have to bottoms up because the 8 over 4 simplifies to the 2. The 4, though, has to come out front. So our final form here, 4x squared minus 1, x squared minus 2. And if you solve them, you actually end up getting these numbers back. We get 1/4 and we get 2. But if they ask you to factor it, then you're looking there. Okay, if you solve 4x squared minus 1, you add the 1, you get positive 1, divide it by 4. You add the 2, you get positive 2. Okay, the last thing we're going to look at is, you're working on a problem, grouping does not work. You can't make it happen. It has 1, 2, 3, 4 terms. But if you tried to find by grouping and say, okay, I see these two have an x squared, I see these two have 13, 6, and 7, there's nothing in common there at all. Okay, so there's nothing we can do to make this work out. So we're going to try synthetic division. So something to remember about synthetic division, we can find the possible factors by taking the factors of the constant over the factors of the leading coefficient. So the factors of 42, so make your little factor tree here. 42 is made up of 1 and 42, 2 and 21, 3 and 3 goes into 4 one time, leaves a 12, 14, let's see, 3 and 14, 4 doesn't work, 5, 6, 7 will be the next one, 7 and 6, and then we'll have 7, so we're done. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 possible factors. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 7, plus or minus 21, plus or minus 42. Those are all the possible factors. Where do our factors play in? Well, and also the leading coefficient here, divide them all by plus or minus 1. So we're actually looking at these numbers. If this were like a 2 or a 4, then we would have to divide everything first. But I believe the one in your paper also has a 1 here in front of it, so we don't have to worry about that. So we're just going to do this example. We have to test these possible factors in synthetic division. And remember, when we do synthetic division, we will, let me remind myself here, we're going to put a number in this little box, and I just want to verify because sometimes it's easy to get backwards. Oops, I think I went too far. Hang on. Yeah. Okay. So we're going to pick a value and put it here. Usually I suggest that you start with these bottom values. Start with 1, start with 2, start with 3. Okay. Our final answer here is positive, so I'm going to try with the positives first. There's going to be some negatives in there as well. Let's just start with 1. Let's test -1. If we see, we're trying to see if -1 is a factor, or we're testing x plus 1. Okay? So we write the coefficients of this polynomial down. So 1, -6, -13, and 42. And we do synthetic division, and if we end up down here with a remainder of 0, then we did the right thing and we're good to go, and that's one of our factors. So let's check it out. If we bring down this 1 and we multiply, -1 times 1 is -1, this becomes 6, -1 times 6 is -6, and this becomes -19, this becomes 19 because -1, -19, this will end up being 40, 50, 61. That is not a decent factor. So what that tells me is, what was happening here? We want this number to end up being negative, okay? So I'm going to try a positive number here now. So let's come in here and try 2, or the factor of x. I believe it's a factor of x minus 2. That's what I'm not positive of right now. Hold on. Yeah. So x minus 2. So let's test that. We keep the same coefficients. Okay? So we bring down the 1. 2 times 1 is 2. This is -4. 2 times negative 4 is negative 8. This is negative 21. 2 times negative 21 is negative 42. That worked. So that tells me we have a factor of x minus 2. Why does that tell me we have a factor of x minus 2? Because I told you one of the zeros was 2. X equals 2, or if I try and get this to become a 0, I subtract this 2 from both sides, x minus 2 is 0. Okay? So we know when I have x minus 2, that leaves that polynomial left. I started with x cubed. So this next term will have an x squared. It is 1x squared minus 4x minus 21. Okay, so remember, these are our next polynomial, and they're made up of these leading coefficients. We start with the original and we take away 1. This was x cubed, we take it to an x squared. All right, then consider your trinomial that's left over. Do I have factors of negative 21 that add up to give me negative 4? 1 and 21. One of these must be negative. So 1 and 21, 3 and 7, 7 and 3, 21 and 1. Is there a pair there that gives me negative 4? Yes. Negative 7 and 3 give me negative 4 when I add them. So my final answer here will be x minus 7 and x plus 3 in place of this trinomial. And don't forget to keep your x minus 2. That comes along for the ride. So fully factored, I have 3 solutions. You'd be looking for one of those 3 as your answer. All right, hopefully that helps you with everything you need. There are a few problems that are set up as word problems. There's words in them. They're not just letters. But for the most part, they just ask you to set up a polynomial and maybe solve it or factor it. There's one that says there's an equation that gives a height in seconds. And when does it hit the water? Well, when will you hit the water? When your height is 0. So you set the equation equal to 0 and you solve it, and you pick the one that makes sense. They ask you about a product of 2 binomials. That's just telling you to factor. Yeah, everything else should be pretty clear. Factor. On the second day, your final answer will be open-ended. So you're going to write in that answer, and I'm going to consider it as an answer. But it's not like you're looking for one answer. So just something to keep in mind on your advanced factoring circuit. Your last answer you should get this week will be something that you create and write in. All right, if you have any questions, shoot me an email. If you feel like a Zoom meeting where you can work back and forth with me and actually ask questions would be helpful, send me an email. I will set up a time to do that. I set 2 times last week. I know they were short notice, but nobody showed up. So that tells me is you don't have any questions that you want to ask me in person. So if I'm wrong about that, totally fine. I will be here for you. Send me an email. Let's set up a meeting time, and I'll advertise that so that other people can participate. But I'm not going to just sit in front of the computer if no one needs help. So I'd love to do that. I'll be here for you. Otherwise, good luck. It's nothing you haven't done before. So this week should feel kind of easy. Next week we're going to do 1 assignment, a 2-page circuit. It's going to be a review of many topics. I'll probably do a couple of examples to help you get through them, and I'll post that up next week. And then we'll be done. So next week your task will be to work on that 1 circuit and to catch up on anything old, anything I've returned to you and said fix it. That'll be what we're finishing up next week. All right, guys, have a good week, and I will be around if you need me.